All right, so the focus of today's lesson was the tangent problem. So like on Friday, we define a tangent line to a curve C at a point P as a line that intersects the curve at just one point P. If you take a look at the images shown, these are all examples of tangent lines. You'll notice that the blue tangent lines intersect the curve at exactly just one point. You will notice, however, in the fourth picture, that the tangent line is only tangent within a certain section of the graph, but you will see that it behaves within that interval the same way as all of the other tangent lines and intersects the curve just once. Whereas a secant line to a curve is a line that intersects the curve more than once. Now, you might say, how is this situation here different from the secant line? Well, if you look closely, you'll notice that in the tangent line situation, that the line is fully above the curve. Whereas in the secant line situation, you will notice that when you look at the line intersecting the curve, it is not fully above or below. And so in this case, it goes through the curve and is not fully above or below. It doesn't just graze across it. So a secant line to a curve is a line that intersects the curve more than once. Now, we're going to look at the same example we looked at on Friday, but we're going to do a little bit more with it. So the problem says, find an equation of the tangent line to the graph of f of x equals x squared at the point 1, 1. So we have here a detailed kind of zoomed in version of our x squared in black, and our point 1, 1, and then some point q close to 1, 1. And if you think about what we did on Friday, remember the goal was to move this point Q closer and closer to point P in such a manner that that green line slowly turned into that tangent line. So we're going to see if we can make that happen. So remember here, point Q is some point 1 plus h, f of 1 plus h. And note this is just a point that is a little bit away from P. And then our secant slope, or m secant, is just the slope between these 2 points. Remember, y2 minus y1 over x2 minus x1. In this case, that is f of 1 plus h minus 1 over 1 plus h minus 1. Now remember, f of x is x squared. So f of 1 plus h is 1 plus h squared. So we have here f of 1 plus h as 1 plus h squared minus 1 over 1 plus h minus 1. Expanding this becomes 1 plus 2h plus h squared minus 1 over 1 plus h minus 1. You'll notice that the 1's in the numerator and the denominator cancel, because 1 minus 1 is 0 in the numerator and 1 minus 1 is 0 in the denominator. We're left with 2h plus h squared over h. Factoring out the h in the numerator, we're left with h times 2 plus h over h. The h's in the numerator and denominator cancel, leaving us with 2 plus h. Now that's what we learned on Friday. Now we're going to add something. We also learned on Friday that if we would like to find the tangent slope, because in order to write an equation, we need a slope, that the tangent slope was given by taking the limit as h approaches 0 of our secant slope. In other words, making that space between P and Q, which we're going to call h, less and less and less. In this case, m secant is 2 plus h. So this becomes the limit as h approaches 0 of 2 plus h. Now because h is getting close to 0, this becomes, instead of 2 plus h, 2 plus 0, which is equal to 2. Now that's step 2. Now the last thing we need is we need the equation of the tangent line. We're trying to create a line, and we know every linear equation can be written in the form y equals mx plus b. So, do we have a point that's on this line? We do, 1, 1. So that's our x and our y. Do we have the slope of this line? We do. That's 2. So we're going to plug in what we know. We know y is 1, M is 2, X is 1, and we're trying to find our y-intercept B. So we get 1 is equal to 2 plus B, or negative 1 is equal to B. Therefore, our tangent line has an equation at y equals 2x, that's our slope, minus 1. And let's go ahead and see what this looks like on a graph. All right, so we're going to use Desmos. If you have your graphing calculator, I recommend using that and playing around with it. We're going to graph x squared, that was our curve, and we're going to graph the point 1, 1. Let's just call it P. And then let's graph our tangent line, which we found to be y equals 2x minus, was it minus 1? Minus 1. When you look closely, you will notice that in fact, at that point, we are tangent, meaning it crosses at exactly one point, and that point that it crosses at is 1, 1. Now, what I recommend you do now is go ahead and, if you can, print out the assignment from today. The document is attached on Teams, and play around with some of the other problems. Feel free to message me with any questions.